I know most of you have heard a lot about the eclipse recently, and you've probably watched a lot of things on the media that explain how it works. It's actually a very simple motion in our solar system. It gets a lot of media attention though because it's fantastic when you see it actually happening in totality, like I hope some of you will this week. Anyway, let's start this, and I'm going on the assumption that tomorrow you'll watch the remainder of this presentation. We'll do that for our Tuesday class, so hang on and try to pay attention to what's going on this beginning part of it right now. But let's look at this, our place in space, the place that God has put us in as planet Earth. Romans 1:20, we've looked at that many times, I know, but it still amazes me that you can look around at creation, and this was the thing that most people saw the very first of history. I mean, before we had any other technology, science, or whatever, people were looking up at the sky, and obviously that was a thing that was clearly seen, like it says here, and it was awe-inspiring because you could look at it and say something intelligent or someone intelligent actually had to make all of this and to design it. So we look up at the sky, and obviously we see things that we don't understand. I think for ancient people, when they looked at the sky, they couldn't tell how far the stars were, and neither can we really. It's hard to imagine how far they really are in light years away from us. And that was, I think, one of the first things that drew people's attention to the sky. The Psalm also tells us that heavens just simply declare the glory of God. So keep those verses in mind and see what you think when we get a really scientific view of what's going on. So here's Earth with sun in the distance. So that is our star, in case you didn't know. Sol, S-O-L, is the name of our star. And in the universe of stars that God made, just countless stars, our star is just an average, medium, slightly yellowish star. Basically a huge atomic bomb going off, or a hydrogen bomb that's going to go off for millions of years, turning hydrogen into helium for the most part. Yeah, just a big burning, or not really burning, but very hot nuclear explosion happening. So look where we are. Earth is right at 92 million miles away from the sun. We do have two planets that are closer to the sun, Mercury and Venus. This picture is a problem though, because when you start trying to draw and define what space looks like, the sizes really get you messed up, because it looks like here that, Earth is, just a little way away from the sun. We just skip over to Venus and skip over to Mercury and we're there. When we look at it though, look at this. The sun itself is about 100 times in diameter what the Earth's diameter is. So what you see here are 100 Earths lined up side by side, and that's about the diameter of the sun when we look at it. So it is huge, 92 million miles away, which is far away, but still huge compared to what the Earth is. Now, if you did draw this to scale, let's say that this was the size of the sun that we're using as our model right now. The moon would just be a speck, and basically the Earth would be a slightly bigger speck. This is still not correct though, because the spacing between the sun and the moon that you're looking at right now and the Earth is not really to scale. So if you imagine the sun the size it is on the projected screen that you're looking at, the moon would actually be out in the parking lot somewhere, and the Earth obviously. So that's quite a ways away. And then when you start looking at the other planets, Mars, Jupiter, and Saturn, they're actually over toward the main building, and still the scale you're looking at. So, we're still talking that the sun is the size you're seeing it, and the Earth would be in the parking lot the size of whatever that grain of sand is that you're looking at. And then Mars, Jupiter, the rest of them would be so far away that we're talking you would have to go to Springdale to see Neptune and Pluto and some of the others at the scale you're looking at. So to me, that's unimaginable that the sun could actually even have an effect on something that far away and that small. Yeah, this shows the actual sizes of things to scale. So if you look at the sun on the top picture, now look at the bottom picture, that same 92 million miles. If the sun were the size of that little pinpoint on your left, we wouldn't even be able to see Mercury, Venus, and the Earth. We also know that if we took into account the other planets, and I'm going to go with saying that Pluto is a planet. They say it's not, but let's just say it is. But this is what we're looking at. This also shows Halley's Comet. It's in a very irregular elliptic around the sun. But look at the other planets that are there. The Earth is in red, so if you look at the red orbit of the Earth, and now the outer orbit there with Pluto and Uranus and some of the others, 7 billion miles across. So Earth is 92 million miles away from the sun, but the entire diameter of the solar system, and that obviously is the diameter of Neptune, it looks like, going around there. Most of them are in a plane, but Neptune and a couple of the others are slightly inverted to that plane. Now look at this. 7 billion miles times 900 is what we call a light year. So when you hear that word, just bat it around like it was just a mile or two. No, think of this. 900 of those 7 billion mile solar systems end to end. So our solar system end to end 900 times is what they're talking about when they talk about a light year. An incredibly large amount of distance. And we also hear the word parsec. We heard this misused on Star Wars. They didn't exactly get it right, but a parsec is actually a distance. And it's kind of difficult to understand what it is, but they use a little geometry to get this. It's approximately 3.2 light years. So when you hear that, it's just a scientific way of measuring very large things. Yeah, look at this. We know what our galaxy looks like. We'll see some pictures of that later. But the picture you're seeing now, every dot that you're seeing is not a star. It's a galaxy just like our galaxy. So keep that in mind. And our galaxy is made up of billions of solar systems just like ours. We'll get a better look at that later. Here's another view of what some star sizes are like. Our sun, we mentioned, was just an average size star. Now look at the red giant to the left. Stars like Betelgeuse and Orion that you see, even though they are huge, I mean thousands of times the volume of our sun, they're still much farther away. So yeah, our sun, obviously our closest star, is very close compared to the other stars that are out there. So here's what we think our cluster of stars look like. Our sun is just a tiny little speck right about there. I mean, it's just an insignificant little star in all of these billions of stars in this thing that we call a galaxy. And ours we've named the Milky Way galaxy because when you look up in the sky, you kind of see a band of, or a part of this galaxy, very small part, but it looks like a band of spilled milk, someone thought, going across the sky. So that is a galaxy, and remember the picture you just saw here where each one of those dots is a single galaxy like ours. So to say that God was amazingly omnipotent in making or creating a universe that, as far as we know, just it's boundless, but we know of at least billions and billions and billions of other galaxies, which each of those have billions of stars within them, and we're still counting. Our nearest star, Alpha Centauri, you have to be in the southern hemisphere to see it, but if you looked up into the sky around the South Pole, if you were there, you would see a tiny little dot that would be our neighboring star that is 4.5 light years away from us. And that means the other stars you're seeing are more than that. We can see some stars that are millions of miles away from us. I think it's amazing here that it says God actually counts the stars and gives names to all of them. So you think of that innumerable number of stars. God is still in control of everything. Okay, let's turn our attention just very briefly here for a few minutes to what you're going to see if you experience the eclipse. Our moon, we call it Luna, or that's the traditional name of it. So Sol is our star, Luna is our moon, from which we get lunar and adjectives such as that. Our moon is unusual in our solar system, though, because this picture isn't exactly accurate, but it's almost there. The sun is way too small, but look at the Earth and the moon. Our moon is about 1/6 the size of the Earth. The other planets have moons that are just tiny little specks compared to their mass. And that's why a lot of people say that Earth and moon are kind of like a double planet in a way. So it does go around the Earth, so we'll keep on calling it a moon anyway. And moon is just the word we use for a smaller object that orbits a planet. So if you look at Jupiter and some of the others, they're still counting. I mean, there are like over 60 moons that Jupiter has going around it. And that's unusual too. Venus has no moons, but the rest of the planets, as far as we know, do have moons around them. The moon is about roughly 1/4 of a million miles away from the Earth, which is much closer than the sun at 92 million miles. So keep that in mind. Earth is very close, relatively speaking, to the Earth or to the moon. The moon doesn't have an atmosphere, so we see craters from years of meteors hitting it and making wreck of it, basically. Aren't you glad we have an atmosphere to protect us from things like that? I was around and watching when Armstrong first walked on the moon, so here's a picture showing that it's a pretty desolate place. I like one of Jules Verne's illustrations here. In his story about going to the moon, we see the face of the moon that people used to think that they could see. Can you see it in this one? Or if you had a little bit of fogginess around, could you see it better with that? And that's why I think it's a little pareidolia. You think you're seeing something that isn't really there. But anyway, just the dark spots called Cs or Maria. Also, this is unusual. You may not know this, but the same side of the moon faces the Earth all the time. And the reason is the moon rotates on its axis exactly at the same rate that it goes around the Earth. And that's kind of unusual, isn't it? Because that means that as it rotates around to, let's say, halfway around, it's made 1/2 of an orbit, and we still see that face that we saw earlier. Other moons don't actually do that, but our moon does, called a synchronous orbit around the Earth. Some people don't understand this either. It's a simple concept. It's just hard to imagine what's causing it. But look at the different phases we see of the moon. If you watch for about 29 days, you would see it go all the way from nothing at all to a tiny crescent, and then getting bigger and bigger to a full moon, and then smaller and smaller to another moon that just disappears and we don't see it. And we have names for those. Waxing means that it's getting bigger. Waning means that it's getting smaller. So a full moon, we see it as fully lit. A new moon, we don't see it because we're looking at the dark, or we're looking at the moon when the side we see is in the dark. We see the same side all the time, but whether it's dark or light changes periodically. So here we are. This is what's happening. A rare event, and the reason it's rare is because you see right now the sun, moon, and Earth are lined up in a straight line. The moon isn't always exactly in that line, so sometimes it's above it, sometimes it's below it, and that's why we don't have an eclipse every single 29 days as the moon goes around. But you do notice this is when we would have the phase of the new moon, right? Because here we are on the Earth, and look where the sun is. The sun obviously is shining on this side of the moon, and this side of the moon is darkness. And it just so happens that if we were on the Earth looking at this moon right now, we would see total darkness, or a new moon it's called. And that's exactly what's happening during the eclipse. The eclipse is a new moon that just happens to be just lined up perfectly so that the shadow of the moon hits the Earth right here. And that's what we'll be seeing. It's just the shadow of the moon. We're looking at the moon, and you'll see the sun behind the moon back here. And interestingly, here's a shot of a former eclipse that we had. For some reason, and remember this, there's absolutely no logical reason for this except God just kind of gave us a gift with this. But you think about it, the sun is 92 million miles away, the moon is 250,000 only, and the distance or the size of the moon obviously is much, much smaller than the sun. But coincidentally, and again I emphasize totally coincidentally, the image of the moon that you see right here is exactly the same size as the sun. Have you ever thought about that? When you look up in the sky, if you held your fingers out and grabbed the moon would be the same relative size as what we see the sun. And that's like if someone were sitting right in front of you in a pew in church and you're looking at the pastor's head way up in front of you somewhere. That person could hold their thumb up and probably cover the entire pastor's body, because it's a function of the person's thumb being much closer to you and the pastor being farther away, even though the thumb is much smaller than obviously a man would be. But that's unusual, I think. Another thing that people look at and say, well, maybe God is telling us something here, that we look at it and say, that's such a coincidence, it couldn't have happened just by chance. Now, once again, here's the eclipse. We have different sections. This is a lunar eclipse, which is not happening right now, but here's the sun shining this way, and the Earth's shadow at this point is covering the moon. We'll talk more about that later also. The moon does have an effect on the Earth other than just light in the sky, because the gravity of the moon, remember, it's 1/6 the size of the Earth and relatively close, so it does pull things up. And we'll talk some about this when we get into some of the more esoteric things about moons and how it affects the Earth. But we have tides on the Earth because the oceans are actually pulled toward the moon, and it makes a bulge on the other side of the Earth in addition to that. So yeah, there is an effect other than just light from the moon. I want to show you one more thing today before we get into something else. If you didn't understand the phases very well, you can check out this Google page. And this shows a student, and you see what's happening? We'll pretend the sun is right here. And so the student is just rotating like the Earth rotates. The student is holding a fake moon that also is orbiting her as she's standing there. But remember, the sun is right here. So think of the sun being here, and you'll notice the sun is always shining on the left side of the student, right here, and also the left side of the model moon she has. But look what the student actually sees if she, from her perspective, is looking at the moon. So watch coming up. Here comes a new moon right now. And see, she sees the dark side of the moon. That's what you'll be seeing during the eclipse. So I hope you get to safely go out and watch it. Be sure to wear the glasses that are made for it. Don't try to glance up at it, but it's really worth going to see. So I hope we can talk more about it tomorrow. Thank you.